Have you ever wondered how everything, from the smallest atom to the largest galaxy, came into existence? It all begins with a theory, a Big Bang theory to be precise. This prevailing cosmological model postulates that the universe, as we know it, began some 13.8 billion years ago. Imagine everything you see, everything you don't see, and everything beyond that, compressed into a single point, a singularity. This singularity was so incredibly dense and hot that it couldn't contain itself. And then, in less than a blink of an eye, it exploded. This explosion, this Big Bang, sparked the creation of the universe. In the aftermath of this explosion, the universe began to expand. It spread out, cooling and coalescing into the cosmic structures we see today. This expansion continues even now, billions of years later. And so, the universe was born, setting the stage for the creation of everything we know today. As the universe expanded, matter began to coalesce, forming the first galaxies and stars. This wasn't a hasty process, mind you. It took billions of years for clouds of cold hydrogen gas to slowly gravitate towards each other, creating denser regions. These regions grew heavier and heavier until the pressure at their core was immense. The result, the birth of a star. Stars are not just celestial bodies that twinkle in the night sky. They are cosmic powerhouses, conducting a symphony of nuclear fusion at their cores. This process involves hydrogen atoms fusing together to create helium, releasing an incredible amount of energy in the form of light and heat. But stars aren't eternal. They age, and as they do, they exhaust their hydrogen fuel, leading to a series of events that can end in a supernova explosion. It's in the heart of these stellar explosions where all elements heavier than helium are born. Stars, the building blocks of galaxies, not only illuminate the cosmos, but are also the forges where all elements heavier than helium are created. From the cosmic forge of a dying star, our own solar system was born. This monumental event was not a mere twist of fate, but the result of a process known as the nebular hypothesis. Picture this. A vast, swirling cloud of dust and gas in the cold void of space. Over millions of years, this nebula, under the relentless pull of gravity, began to spin faster and flatten into a disk. At the heart of this disk, where the pull was strongest, matter began to clump together, growing hotter and denser. Eventually, the pressure became so great that hydrogen atoms began to fuse together, releasing an enormous amount of energy. This marked the birth of our sun, a fiery orb of gas, burning brilliantly in the heart of the nebula. But what of the rest of the nebula? As the sun blazed into life, the remaining dust and gas were not left idle. They too felt the pull of gravity, the particles colliding and sticking together, forming larger and larger clumps. Over time, these clumps became the planets, asteroids, and comets we know today, each with its own path, carving out an orbit around the newborn sun. The creation of the solar system was not a swift process, but a gradual one, spanning millions of years. Yet each step was crucial, setting the stage for something extraordinary. With the formation of the solar system, the stage was set for the development of life as we know it. On a small blue planet in the newly formed solar system, life emerged. Imagine a world light years away from what we know today, a world devoid of the bustling life, the trees, the animals, and us. The Earth was once such a world, a barren expanse of rock and water. Yet in this seemingly inhospitable environment, life found a way. But how? One popular theory is the primordial soup theory. It suggests that billions of years ago, the Earth's oceans were a rich mix of chemicals. Over time, through a series of reactions fueled by the energy of the sun, these chemicals combined and recombined to form the first simple life forms. Yet not all scientists agree. Some propose an alternate theory, panspermia. Panspermia suggests that life did not originate on Earth at all. Instead, it was delivered to our planet by comets or meteorites carrying microbial life from distant parts of the universe. Regardless of how life started, what's truly fascinating is how it evolved. From the first simple single-celled organisms, life on Earth has blossomed into an incredible array of complexity and diversity. Over billions of years, through a process of natural selection, these primitive life forms evolved into the multitude of species we see today, from bacteria to blue whales, from fungi to us, humans. The evolution of life on Earth is a testament to the resilience and adaptability of nature. Now, billions of years after the Big Bang, we find ourselves in a vast universe, still expanding and full of mysteries. In the blink of a cosmic eye, we've gone from the explosive birth of the universe to the serene cosmos we observe today. Yet this seemingly tranquil universe is anything but. It continues to expand, with galaxies moving away from each other at an accelerating rate. This expansion is driven by a mysterious force we've come to know as dark energy, a concept that remains one of the biggest enigmas in modern astrophysics. And let's not forget about dark matter. Even though we can't see it, we know it's there. It's the invisible scaffold on which galaxies are built, and it makes up about 85% of the universe's matter. Yet, despite its prevalence, it remains elusive and largely undefined. We also find ourselves asking, are we alone in this vast universe? With an estimated 2 trillion galaxies, each teeming with billions of stars, the potential for life elsewhere seems plausible, if not likely. The search for extraterrestrial life is one of the most exciting frontiers in space exploration, and who knows what discoveries await us. Looking even further into the future, we're faced with questions about the universe's ultimate fate. Will the expansion continue indefinitely, leading to a big freeze where stars burn out and galaxies drift apart? Or is there a big crunch in our future, a cosmic collapse leading to another singularity and potentially another Big Bang? As we continue to explore the cosmos, we are reminded of our humble beginnings in the grand cosmic narrative and of the infinite possibilities that lie ahead. With each new discovery, we gain a deeper understanding of our universe, and yet, we're also reminded of how much we still don't know. It's this endless pursuit of knowledge that propels us forward, pushing us to explore the farthest reaches of the cosmos and beyond.